Okay, we begin our review of Chapter 5. The first part of the review, I'm going to go over the first quiz, which is the first part of the module, algebraic expressions, and then on the back are solving the equations. The next quiz will focus more on word problems and inequalities. So this kind of gives you a review. Nothing you see on here you haven't already seen on your practice test, but it's just kind of a good summary, good thing to study before you take your test and your quiz. So show all work. Are the following equivalent? So the first thing I would do for number 1 is I would change it from 3 over 1, from 3 divided by 1 to 3 over 1, and then 1 divided by 3, 1/3. So that makes it a lot easier to see they are not equivalent. This is 3 whole pies, and this is 1/3 of 1 pie. So definitely not equivalent. This is one we talked about. I think on the practice test it was 2/3. So this is 1/3. 1 divide, whoops, turn the calculator on, Kim. 1 divided by 3, we can see is not 0.3. Remember, equivalent means they're identical. And this is 0.3000000, where this is 0.33333. Is this an approximation of that? Yes, but approximation does not mean equivalent. So what I would write is 1/3 equals 0.3333 ... is not equal to 0.3. Because you want to write as much as you can on this so you have it to study, to understand why the answer is yes and why the answer is no. We learned that when the x is out to the side, it's really x over 1. So if this was x over 1 and you multiplied, which this is multiplication, you multiply the top numbers. 2 times x is 2x. 3 times 1 is 3. And that is not the same thing as 2 over 3x. So that would be what I would write on my paper, just so you know the difference. So when there's a whole number out there, that means it's over 1. I'm going to turn my light on so that there's no shadow. So 2 times x is 2x. 3 times 1 is 3, because in multiplication we multiply straight across. So another no. This was also on your practice test. We said that negative 1/3 is the same thing as 1 over negative 3, which is the same thing as negative 1 over 3. So all 3 of those are equal. What matters is that each one has one negative sign. One negative sign means the answer is negative, and 1 divided by 3, we just saw all 3 of them would be negative 0.333333333 when we type them in the calculator. So those are absolutely equal. And this one stems from this one. Again, all you have to do is put x over 1 here and multiply straight across. 1 times x is x. 5 times 1 is 5. So yes, they are indeed equal. So the moral of the story is the x will always go in the numerator when it's out to the side like that. This is a more typical way to write it. You could also just argue it this way. This is the same thing as 1/5 x. So however you want to show yourself why they're equal, either one of those are good arguments. Okay, this also was on the test. I think on the practice test it said, are they equivalent? On this one they're saying true or false. So same thing, are they equivalent? So when we distribute this, because remember you have to simplify whichever ones you can simplify. So negative 2 times x minus 3 would be negative 2x. And a negative times a negative would be positive 6. So these two are not the same, so this would be false. And this one, not in alphabetical order, so put it in alphabetical order to inspect the two. 5x cubed y and negative 3x cubed y. And remember, the definition of like terms means they have the same variable and the variables have to have the same exponent on them, and they do. The x's both have 3's and the y's are both to the first power. So those are like terms, so that is true. So like I said, all stuff you saw on your practice test. This is just a little review to make sure everybody's good with everything. And here's the translations. Maybe you want to turn off the video and do those first before you before we go over them, because the other ones it's kind of not too much work there, but these definitely take some work. So I would turn the video off and then come back and we'll go over them as soon as you get them done. Okay, product we learned means 2 parentheses. And since the product is one of our 4 keywords, and remember product means multiply, but we do parentheses because usually one or both have to be in parentheses. Since that's one of our keywords, that says to look for the word and, so you know what goes in the first parenthesis and what goes in the second parenthesis. So the first parenthesis should just have negative 3, so we can see that we can drop that since it's one term. The second parenthesis has some, so a number and 5, so x plus 5. So when we go to write it here, we generally drop the parentheses. It's not wrong to keep them, but it's simpler to write them this way, because sometimes they'll say translate and simplify. This is a simplified answer. This is not. Okay. 3 more than x. So we learned that that means x plus 3. And remember, because it's addition, order doesn't matter. So if you wrote 3 plus x, that's fine. But we just said to be consistent, anytime you see more than or less than, just put the number second. Is no less than. So you guys remember the trick I told you for that? Put a T in. Is not less than. Well, what's not less than? Greater than or equal to. Those are both not less. So is not less than means greater than or equal to. 2 less than x. Both of those are x? I guess so. Thought it was going to be a x on one side and a y on the other. I have that covered up, but I think it's an x, right? And look on my other one. Yep, both of them are x's. So x plus 3 greater than or equal to x minus 2, because the less than says put it on the other side. Okay, so for number 10, 5 times a number is, so remember, this is not a greater than. It doesn't say is more than. If it said is more than without the 7 there, it would be a greater than symbol, but it says is 7. So in this case, the is just means an equal sign. The only time it's an inequality is if it says is more than with no words in between. Is less than, no words in between that. But that 7 is there. Therefore, you can't use an inequality symbol. This is just an equal. 7 more than, so that means we're adding 7 at the end, just like less than we subtract 2/3 of that number. So the number's x, so 2/3. And remember, of means times x. And of course, you could write that with or without the times sign. So I think that exact one was on your practice test, or one very close to it. I remember having the 2/3 x. The biggest thing students do wrong on this on the test is they forget the x. But that means 2/3 times x, not just 2/3. So be careful with that. 2/3 times n. Okay, so that's the front page. Pretty much everything that was on the front page of your practice test. Whoops, got my pages mixed up here. Here's the back page. So also on the front page of your practice test was an evaluate, and we learned that means just plug the number in, find the answer. So we're putting -7 in place of x. So 3 parentheses -7 minus 5. And when we were doing this one in our earlier video, we said you have two options. You could do what's inside parentheses first and then multiply by 3, or you could do the distributive property. It really doesn't matter. I think most students would probably do what's inside parentheses first, so I'll do it that way. When the signs are the same, we add and keep the sign. So that would be -12. And 3 times -12, one negative gives me a negative answer. 3 times 12 is 36. Nice and easy, right? So just to practice on your solving equations, I would probably shut off the video and do all 6 of these, because they're all 6 going to be on the test. So just make sure you're good, and then any ones you miss, circle them to remind yourself to study them before you get to the test. And maybe even if you miss it, rather than erase it, just cross it out and then write the correct work on the side. That way you can say, oh yeah, I got to remember not to do that on the test. I have to do this. So I would recommend doing these 6 first. Best way to get ready for the test. And then come back and check them. Okay. Okay, for this first one, and I'm going to do all the fraction problems the same. The minute I see a fraction, step 1, I'm going to multiply everything by the LCM, which remember is like the common denominator. Well, this one just has one denominator. So that means it has to be the LCM. So the LCM is going to be 5. So put a 5 in the numerator and put a 5 beside every single term all the way across. And remember, if you didn't do it this way and you got the right answer, don't erase. If you got the right answer and you subtracted this first and then multiplied both sides by 5, that's fine. I'm just trying to be consistent. I'm going to do this one the same and this one the same. So all the fraction problems except for the proportions. We learned a different way to do those where we set our cross products equal. But just to me, consistency is everything, because then students don't go, oh, is this the kind where I do? Just do them all the same, and then you'll never ask that question. Always multiply by the LCM first, and then you'll always get it right. So 5 divided by 5 is 1. That's gone. So now I have x plus 20 equals -5. Woo-wee! A little one-step problem after we get rid of the fractions. That's nice. So subtract 20, x equals, when the signs are the same, we add and keep the sign. Nice, right? And I want to check a couple of these. So how about we check 13 and 14, because they're a little bit busier ones, probably the busiest on the page. Just to remind you, every problem where the directions say solve on your test, and there's going to be a lot of them, can be checked. So finish your test first. Don't submit it. Go back and maybe on your paper circle the ones that can be checked. And then you can go back and go, oh, I need to go back and check 20 through or 12 through 17. They're all problems that say solve. So if you circle them on your paper, that will remind you to go back and check them if you have extra time at the end. And then we write our answers. That says to circle them, but Alex likes you to put them in set builder notation, so I'm going to stay with that. Okay, so that's the same thing as circling, putting your answers in the set notation. Okay, let's look at this next one. I see we have parentheses. Parentheses are always first, according to Please Excuse My Dear Aunt Sally. So we have negative 16y minus 14 plus 4y plus 12 equals 10y. So negative 16y minus 14 plus 4y plus 12 equals 10y. And then we have two sets of like terms on the left. So negative 16y and positive 4y would be our first ones. When the signs are different, we subtract and keep the sign of the larger. And same thing with the numbers. We have two numbers. When the signs are different, they are negative, positive. We subtract. 14 minus 12 is 2, and keep the sign of the larger, negative 2. So here's another one. I think this is the 5th time we've seen this. If you bring the 10y over, you're going to have a blank there. So either one, you have to remember to put 0 when you bring it over, or what we've been doing in class is just adding the constant over first, so you won't have a blank side, because you do not ever want to have a blank side. If there's nothing there, you fill in 0. Because what students do is they start solving the problem on the left side, and you can't. Every equation has to have two sides, a left and a right. So that leaves me with negative 12y equals 10y plus 2. So all of my constants are now on the right. Now I need all of my variables to the left. And I will tell you this is one of the most missed on the test, and I'll show you why. So when you check your work, see if you did this. So this is negative 22y equals 2. And so what many students do on the test, especially the ones that put the y's on the right, they divide both sides by 2. Never. You divide by what's in front of the y. So I'm going to move this one up here just so we don't cheat it out of space here. So we have negative 22y equals 2. So we do not divide both sides by 2. We divide both sides by negative 22. And then some students do this step right, and then they still write the wrong answer. They write negative 11. No. Negative 22 divided by 2 is negative 11. This is 2 divided by negative 22. So get this out of here. So first thing I'm going to do is put my negative in the numerator. Second thing I'm going to take note of is that there's something common here. 2's common to both of these, and yes, all of your answers do have to be simplified fractions, and I'll show you how to simplify this on your calculator too. So 2 divided by 2 is 1, and 22 divided by 2 is 11, and we can ignore the negative because we moved it up to the top. So 2 divided by 2 is 1, 22 divided by 2 is 11. So the answer is not negative 11. It's negative 1/11, which is very, very, very different than negative 11. So I said we were going to do the check on this one. So let's go down to the bottom and do the check, okay? Because this one doesn't take very much room. I think it's a two-step problem. So we'll do the check over here. So let's just draw an arrow. I just want you to have a couple checks on your paper just so you remember how to do them appropriately. So next thing you do is you write the original problem. So negative 16y minus 14 plus 4 times y plus 3 equals 10y. And we're checking y equals negative 1/11. And it's going to be all calculator. So the hardest part is just writing it because there's so many terms. The easy part's doing the calculator. So we'll do everywhere we see a y, 1, 2, 3 places, we put in negative 1/11. And because it's negative, and this is something you're going to learn along the way, keep relearning. Anytime you input a negative into an equation, it must be in parentheses. So negative 1/11. And the reason why is if you don't put it in parentheses, that means it's subtraction. So that's why we put it in parentheses so it doesn't get mixed up with subtraction. Now this is subtraction. Subtract 14 plus 4 times negative 1/11 plus 3 in parentheses. Does that equal 10 times negative 1/11? And you remember how I told you can do this whole thing in one step on the problem in the calculator. The whole left side can be done as one step because our calculator is really, really smart. It knows all the order of operations and everything. So this is a great problem to practice on your calculator. Make sure you know how to check it. And the check is just as fast as whole numbers. So remember that all of these are negatives. Negative, 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 negative. The only subtraction sign in the whole problem is there. So that's the only time you'll use this. All the other ones will use the negative at the bottom of the calculator. So negative at the bottom of the calculator, 16, parentheses, negative at the bottom of the calculator, 1 fraction bar 11. Close your parentheses. Subtract 14 plus, and I'm looking at my calculator screen the whole time I'm typing this to make sure I'm getting it in right. 4 parentheses, negative at the bottom of the calculator, 1 fraction bar 11 plus 3, close your parentheses. And that gives me negative 10/11. And then I do the other side, and hopefully you can see this is negative 10/11 without doing it, but I'll still show you. 10 parentheses, negative 1 fraction bar 11, close. And it's negative 10/11 because in multiplication we multiply straight across, right? Negative 10/11. So look at that. Piece of cake to check as long as you know your calculator. So I can go back and go, oh, that big ugly one, I'm sure I got it right. And do you know how many people write negative 11 for this answer? And all they would have had to do was check it and see that it was wrong. So then we write negative 1/11 in our solution sets. So be careful. I know there's one like this on the test, and students don't listen to what I said about keeping the y's on the left, so they end up with this problem. 2 equals negative 22y, and guess what they do? They divide both sides by 2 because they didn't put this on the left, and they get it wrong. So they do the whole problem right until the last step. So that's why I never leave my y on the right. For that reason right there, because you wait till you see how many people miss this problem on the quiz. And I go, well, remember when I said always keep your y's on the left? Because we always divide by what's in front of the y, not the number on the left side. Which, if you keep your y's on the left, will be the number on the left side. Okay, so that was kind of a long one. So this one, LCD again, is very easy because there's only one denominator. 4's denominator is 1. These both have 3, so the LCD has to be 3. So let's write the problem nice and big over here. We got to leave room for the check. And I purposely picked 2 with fractions in it to do the check, just to show you how easy it is. You just have to know how to use your calculator. So our LCD is 3. And remember, you can't skip any terms, because I'll see students skip this and I'll go, why'd you skip that? Oh, I was just trying to get rid of the fractions. No, 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 no. The rules for equal says all the terms or none. You don't get to pick and choose. Oh, I'm just going to multiply these 3. Nope. You just missed the problem. So even whole numbers get multiplied. All or nothing. And then the first 2 immediately cancel. This one cancels, and this one cancels. So our next step is fraction free, my favorite. So 5x plus 12 equals 2x. And once again, we have that x over there, so let's go ahead and move our 12 over first, so we don't have a blank there. And that leaves us with 5x equals 2x minus 12. Now we need to move the 2x across because we're crossing the equal sign. We do need to do the opposite. So subtract 2x. Don't just do 5x plus 2x. No can do across an equal sign. So 3x equals negative 12. X is negative 4. So for our check, this one will be a lot easier than the last one. We just need to put negative 4 in for both of those x's. So let's write the original first. 5x plus 3 plus 4 equals 2/3 x. And we're checking x equals negative 4. So again, we're inputting a negative. So every time you input it, make sure it's in parentheses. So you don't think it's 5/3 minus 4. It's 5/3 times negative 4. That's why the parentheses are needed. Plus 4, is that equal to 2/3 times negative 4? Type the left side, type the right side. If they match, go ahead and put negative 4 in solution sets. So 5 fraction bar 3 parentheses negative 4 plus 4 gives me negative 2 2/3. And we don't care about mixed numbers. That's fine when we're doing a check. It's just for our answers. We usually don't want mixed numbers, but for a check, it's fine. And then 2/3 to fraction bar 3 parentheses negative 4. Ding, 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 ding. Same number on both sides. Woohoo! We love it when that happens. And remember, don't type this into Alex. All that this is these have to be the same. This is our solution, and that's why I always put a line, so I look over here to type my solution into Alex. So this would be -4. So that one wasn't bad, was it? Wasn't bad to solve, wasn't bad to check. Okay, so next we have one with some parentheses we have to get rid of first. So we have -6 times 2x, which would be -12x. And we have -6 times -5, which would be +30. Equal to, so -12x plus 30 equals -27 and -12x. So -12x plus 30, and this side is -27 minus 12x. And the minute I see the same x's on both sides, I know this problem is all real numbers or no solution. So anytime the x's are the same on both sides, that means they're going to cancel on the next step. So to bring all the x's to the left, we have to add 12x and bring it over here, add 12x. And as you can see, it cancels on both sides. And the most common mistake, which I know I've already told you, broken record here, is students write x. Don't write x. That means 1x. 12 minus 12 is not 1. It's 0. They're gone. Don't write anything below it. Bring down what's left. 30 equals -27. And we say always true or never true. And this is never true, which means no solution. And like I said, I'm not sure whether Alex is going to offer you to pick a no solution out of the toolbox or if it wants you to write empty set. So if you don't see a no solution to pick, then you just do the empty set, which is the same thing. So haven't seen one of those for a while. Now these are both proportions, and because we only do it one day, sometimes students kind of forget about them. But how do I recognize them? First off, I recognize them because 1 fraction equal to 1 fraction. 1 fraction equal to 1 fraction. So we learned whenever it's a proportion, the easiest by far method is setting your cross products equal. So 3 times x plus 1 equals 2 times 2x plus 3. And remember when we did this one in class, we actually did 2 of these in class. Remember how I said that quantity of 2 or more always have to be in parentheses because that 3 needs to distribute to both, just like the 2 needs to distribute to both. Without parentheses, you would only be multiplying the 2 by the 2x and the 3 by the x, and you'd get the wrong answer. So be careful with that. And that's why we review before tests, because we haven't done this for a while. And if students don't go back and review, they forget how to do these and go, oh, I forgot how to do it. But now you have no excuse, right? So 3x plus 3 equals 4x plus 6. So 3x plus 3 equals 4x plus 6. All x's need to move to the left, so do the opposite to cross the equal sign, and we get -1x plus 3 equals 6. All constants to the right, so do the opposite to cross the equal sign, and we get -1 times x equals +3. And the opposite of times -1 is divide by -1, and that's why I put that times sign in to remind me what to do with that negative. Opposite of times, divide. Double negative, 1 divided by 1 is 1x. 3 divided by -1 is -3. So as you can see, as long as you study that and remember it, those are easy problems. You just got to remember the parentheses, you got to remember to set the cross products equal, and you have to remember it doesn't matter which one you put on the left and which one on the right, they're equivalent. So if you put this one on the left and this one on the right, you would have gotten the same answer. And then this one's done the same problem. It's just a simple little cross products. And when we only have a single x, I suggested that we always start with the x cross product, then you already have it on the left. So 24x equals 18. Oh, and I just remembered I told you up here that I would show you how to simplify this in your calculator too, and then I forgot to show you. So when you type it in the calculator will not let you put a negative in the denominator. So to simplify that in the calculator, you need to move it up before you type it in, and you just type -2 fraction bar 22, and it will give you the correct answer. Okay, so you can always simplify your fractions in the calculator, or after you do them by hand, verify it in the calculator. You just have to remember, because watch what happens if I type it in like this. 2 fraction bar -22, it says no can do, no negatives in the denominator. So that's the only thing you have to remember, is to move that negative up to the numerator. No negatives in the denominator of a fraction. Okay, last problem. So 24x equals 18. Opposite of times is divide. And here's another one that I would probably simplify by hand and then check it on the calculator. So 6 goes into both of those. X equals 3/4. And you could have started with 2 and then simplified by 3 on the next step. I just knew 6 went into both of them. So if I want to check it on the calculator, I just type in 18 fraction bar 24. Just don't depend on the calculator, because remember, there's going to be some tests in your future where you don't get to use it. So that's why I always do it by hand first, then verify it on the calculator. So 3/4 would be our solution. So that is a review of the first half of Module 5. It was algebraic expressions and solving equations, lessons 1 through 3. The next quiz will cover the second half. Okay, I'll see you then.